Remember, nobody will ask the questions on Java, history and all in the interview. As a student, you should be knowing this. If you ask me, sir, what is the history of Java? When did Java come into picture? You know, in the 1970s, C was a hero. It was the most popular language in 1970s. In 1980s, C++ was very much popular language. But in the 1990s, things changed. What changed, sir? So in the 1990s, there was one company called as Sun Microsystem. What this company thought is, they wanted to develop a new programming language in order to support the electronic devices. That electronic devices may be TV, set-top box, or remote or switches. In order to develop the new programming language, they formed a team of 30 members. And for this team, they gave the name as Green. And this team was headed by a person called as James Gosling. One more person, Patrick Norton. One more person, Mike Sheridan. So these people were heading the 30 members team, and they got that team as what? Green team. And they started to develop this programming language in order to support the electronic devices. But that programming language did not go well, because that programming language was very much advanced in order to take care of that electronic devices. But in the year 1990s, internet was booming. Then these people thought, okay, why can't we modify our programming language to support the internet? Then they developed a new browser called as Hot Java browser. People were really happy to use that browser. And many of them were asking the questions, hey, Sun Microsystem, how did you develop that browsers and all? In the year 1996, Sun Microsystem told that we have developed this using one technology called as Java, and the first version of Java was released, that is Java 1.0. That version was released. But from the beginning itself, they called the name as Java? No, sir. No. Initially, they started to call that programming language as Green because their team name was Green. But somehow they felt Green is not a right word. Then they changed to Oak. Oak is a tree name. Then after some time they felt even Oak is not so good. Then finally they changed to Java. So that is how this name came. And the Java programming language was released in the year 1996, the first version. Okay, sir. Till now, how many versions are there? Till now, 14 versions. So that is, the latest version is Java 14, which is released in March 2020. And again in September, they will be releasing one more version, Java 15 actually. What are the versions and all? I am going to display. Again on versions, nobody will ask the questions in the interview. Which version was released in January 20, like that, no questions will be asked. But as a student, you should be knowing which is the latest version. The latest version is what? Java 14. What we will be using in our sessions is Java version 8. Now we may ask one question, sir. Latest version is 14. Why 8th version we are using, sir? Because Java 8 is the version which is widely used in the market, which is very popular in the market. And that's the reason even we are using that version itself actually. Many of the people or industries, many of the other corporate people, they are still using Java version 8 only. For a freshers, Java 8, whatever the features are present, that is more than sufficient for you people to clear any interviews. Hence, we will be also using the Java 8. Maybe at the end of the sessions, I will be telling what are the other features that is added in the new versions and all. So, this is the overall history of Java. Now, take the points. Sun Microsystem developed Java. Sun Microsystem developed Java. Sun Microsystem developed Java. Full stop. In the year 1991, in the year 1991, Sun Microsystem Sun Microsystem form a group of 30 members. Sun Microsystem form a group of 30 members, which is called as a green team. Which is called as a green team. Which is called as a green team. Which is called as a green team, headed by James Gosling, James, space Gosling, James Gosling, in bracket father of Java, comma, Patrick Norton, Patrick, space Naughton, comma, Mike Sheridan, Mike, space Sheridan, Sheridan. Full stop. This team was supposed to develop a new programming language. This team was supposed to develop a new programming language. In order to support electronic devices. Full stop. But the technology developed by Sun Microsystem was too advanced in order to support the electronic devices. Full stop. However, it was suitable for internet. Full stop. Hence, in the year 1996, first version of Java was released. In bracket Java 1.0. Full stop. Initially, for the technology developed by Sun Microsystem, they gave a name as green. Then again renamed to oak, OAK. Then again renamed to oak. And finally to Java. Full stop. In the next line note. Now Java Sun Microsystem. Is not a product of Sun Microsystem. Is not a product of Sun Microsystem. It is acquired by. It is acquired by. It is acquired by. It is acquired by Oracle Corporation. Oracle, O-R-A-C-L-E, Oracle Corporation. Oracle Corporation. In the year 2010. In the year 2010. In the year 2010. Yeah. See, till 2010, the Java was a product of Sun Microsystem, but in 2010, whatever the Java that was developed by Sun Microsystem, it is taken over by the Oracle Corporation. Now in the interview, they ask like, who owns Java? It is Oracle Corporation. So this much is the story of the Java, and I will be displaying the versions of the Java also, from Java 1 to Java 14. You can just make a note of it. So take down the next study, versions of Java. See, again I am telling, nobody will ask this question in the interview, but as a student you should be knowing it, because in the interview if they ask what is the new version of Java, you should be able to answer that the new version is Java 14 released on March 2020, like that. So next study, versions of Java. Copy this. This question, whatever we are going to discuss now, is very important because multiple times this question they have asked in the interview. Take down the question. What is meant by platform dependent? 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 And platform independent. And platform independent. And platform independent. Question mark. Is Java platform independent or not? Is Java platform independent or not? Is Java platform independent or not? Yeah. Pay attention what it means. Now assume I have a computer. This is the computer that I have. I will call this computer as computer 1. And in this computer, I have Windows operating system. So Windows operating system is there in this computer. Now in this computer, I will write one C program like this. One C program I will be writing. You know, whatever the program that we write, that program only we call it as the source code, and it will be in high level language. It means the language that user will understand or the humans will understand. So basically high level language will be in English only always. And the fellow who execute this code is microprocessor, and microprocessor will understand only zeros and ones. And not only that, if a program has to get executed, means it should come and sit in one memory called as RAM. This story already you know it. Now, in order to convert this C program from high level to the machine level language code, I will use one software called as compiler. The compiler will generate the machine level language code like this. So compiler duty is to convert high level language code to machine level language code. Some people also call it as object code or machine code. Same thing, machine level language code or object code or machine code. And the file generated by the compiler, we call it as obj file. That is an object file, because inside this only zeros and ones will be there. Next what, sir? Next I will use one more software called as the loader software, which loads this binary code onto the RAM, that is 101, 010, 000. This will be taken by the microprocessor and it will produce the output. This story you already know it. Now assume I have few more computers. This is computer 2. In this computer I have Windows operating system. Assume I have one more computer. This is computer 3. In this computer, I have Mac operating system. I have one more computer, that is computer 4. In this, I have Unix operating system, and I have one more computer. This I will call it as computer 5. In this, I have Linux operating system. Like this, different computers are there. Now in all the computers we have a processor also. Here also processor, here also processor, here also processors are there. What I will do is, I will copy this machine level code to all the computers. To all the computers I will copy this code. If you ask me, sir, how do you copy this code? Maybe this object file I will copy in a pen drive, from the pen drive I will copy in all the computers, or I will connect all the computers in the network. Through the network I will transfer this file. Now I will copy that machine level language code 101 like this. In all the computers I will transfer. Here also, here also. Like this. Now I will try to execute the code. Here also I will execute the code. Here also I will execute the code. Here also I will execute the code. So first, in this computer, I will write the C program, I will compile, I will get the object file, that I will load onto the RAM, I will give to the microprocessor, I will get the output. No issues. Now I will copy this machine level language code. This machine level language code, I will copy in all the systems. Now I will try to execute. If you ask me, sir, what will happen? Here I will get the output, but in this computer I will not get the output. Here also I will not get the output. Here also I will not get the output. Now many of them will be wondering, sir, why sir in this computer we are getting output but in the other computers we are not getting? Why means? Because C is platform dependent language. What does it mean, sir? First of all, what is platform, sir? Platform is nothing but the combination of operating system and processor. Both operating system, processor put together only we call it as what? Platform. So in this computer, we have written the program in the Windows operating system. We have compiled also in the Windows operating system. We are trying to execute in the Windows operating system, no issues. But come here. Whatever the compiled code that happened in Windows operating system, that compiled code is nothing but machine level code. That machine level code I am trying to execute in Windows operating system. Here Windows operating system, Windows operating system. So compiled code is also from Windows operating system. The execution also happening in Windows, hence you will get the output. But in this case, your code is compiled in Windows operating system, you are trying to execute in what? Mac operating system. So your operating system mismatch is there. Hence you will not get the output. So what is meant by platform dependent, sir? Platform dependent means if a program is compiled in one operating system and if it is executed in the same operating system. See here, I have compiled in Windows. If I execute in Windows, only I get the output. Then such programs are only called as what? Platform dependent. But in these two cases, in this also, I am trying to execute in different ways. Hence, I will not get the output. Hence, your C program are called as what? Platform dependent. Platform dependent means if a program is compiled in one OS and if you are trying to execute in the same OS, then only you will get the output. Otherwise, you will not get the output. Not only that, even C++ is also platform dependent. Why, sir? Why it is platform dependent, sir? Why means a very important point. Whatever the machine code that you get, always remember this is very, very important point. This machine code is machine dependent. What does it mean, sir? Whatever this binary you got it right, tell me this binary you got in which operating system? Windows. Then this particular binary file will get executed only in Windows operating system only. That is how your computers has been designed. So your machine code or an object code, it is always machine dependent. So if I compile in Windows, then I can execute only in Windows. That was the problem with C++. Okay, sir, if it is platform dependent, what is the drawback? What is the drawback means it affects the business. Assume you develop one gaming software using C language. I write the code for that gaming software in Windows operating system. Then think and answer. If someone wants to use that gaming software, then in which particular operating system he can use? He can use only Windows operating system. We can't use that gaming software in other operating system. Don't you think so you are losing the business? Because out of 100 people, don't tell everyone will use Windows only. Out of 100, maybe around 50% will use the Windows operating system. The other 50% will use different operating system. Then don't you think so that you are leaving the 50% of the business? In order to overcome this problem only, one new programming language came into picture. What is that? And all those stories I will tell you. But did you understand the concept of platform dependent? So what is a platform? It is a combination of operating system and processor. So what is platform dependent? If a program is compiled in one operating system and if it is executed in the same operating system, then if you get the output, then such programs are only called as platform dependent programs. Am I completely clear? Any confusions in this? And your machine code, whatever you get, it is always machine dependent. Means this machine code you can execute only in Windows operating system. Now some students will get one doubt. Sir, assume here Windows operating system is there. Here I have Intel processor. Just in case here in this computer I have Windows operating system. The microprocessor that I am using is AMD. AMD microprocessor I am using. Will I get the output? No, you will not get the output because processor mismatch is happening. So platform means both processor and operating system is considered. Then tell me if you want to get the output, here also which processor should be there? Here also Intel processor only should be there. So Intel matching, Windows matching, you will get the output. Here, forget about the processor, operating system only not matching, no output. Here also no output, here also no output. I hope you got to know what platform dependent means. Take down the points. Platform is a combination of software in bracket operating system and hardware in bracket processor bracket close environment. So that's what I told. So platform is nothing but the combination of OS and the processor. OS means operating system. In the next line, platform dependent hyphen a program is compiled in one operating system. And if it is executed only in the same operating system, then it is platform dependent. Full stop. Example C, C++. Hope everyone understood. So platform is nothing but the combination of software, which is operating system, hardware, which is processor. And what is platform dependent? A program compiled in one operating system can only be executed in the same operating system, then that is only called as the platform dependent. Hope you understood. Copy this diagram, pause and copy it. So now we will see what is platform independent. Pay attention, lot of new important features you are going to learn in this example. So assume I have one computer like this. This is the computer that I have. And in this computer, I have Windows operating system. So Windows operating system I have. I will call this computer as computer 1. And I have some more computers. This I will call it as computer 2, where I have Windows operating system. I have one more computer, computer 3, where I have Mac operating system. I have one more computer. This I will call it as computer 4, where I have the Linux operating system. I have one more computer. I will call this as computer 5, which is maybe Unix operating system. Now in this computer I write a Java program. Java program I will be writing. You know the program that we write, that code only we call it as source code, and it is written in high level language, because in English everyone can understand and can read that English. And same story, to execute I should have the microprocessor also, and the code should commence it in one memory called as RAM. This story you already know this. Now what will happen? Pay attention. Now I will give this program to one compiler, and that compiler I will call it as Java compiler. And when I give this program to the Java compiler, many of them think what is the file that I get is a machine level code file, but Java is completely different. So when a Java program is given to the Java compiler, it will not generate the machine level code file or object file. Rather, it will generate one file called as class file. And inside this class file, I will be having something called as bytecode. Oh, what is bytecode, sir? What is class file, sir? Very simple. Whenever you give a Java program as input to the Java compiler, the file the compiler generates is only called as what? Class file. I repeat once again. Class file is a file which is produced by the Java compiler after executing what? Java program. And what will be there inside the class file? Bytecode. And if you ask me, sir, what is bytecode? This is only bytecode. So bytecode is a code which is generated by compiling Java program. Class file is a file which is obtained by compiling the Java program. Okay, sir, but what is really a bytecode? So bytecode is such code which is neither high level language nor machine level language. You know, whatever the code that we write, that is high level language, you can read it. Int a comma b comma c is equal to a plus b, like that. Machine level language code means you know 1001 in the binary. So your bytecode is such code which is neither machine level, which is neither high level. A भी नहीं. Such code is only called as what? Bytecodes. So once we start writing the Java program, I will open the class file and I will show you the bytecodes for you people. Then you will understand, oh, this code is not completely high level also, completely machine level also. Hence that code is called as what? Bytecode. But till now, just remember this definition. The file which is obtained by compiling a Java program is called as a class file, and the code that is obtained by compiling the Java program is called as what? Bytecode. Now, a very important story. In order to convert this bytecode into machine code, if you ask me why we should convert, because your microprocessor can execute only what? Zeros and ones. So in order to convert this bytecode into machine code, in your computer, you should install one software called as JVM, which is called as Java Virtual Machine. So that software you should install. And always JVM will be present inside the RAM only. So whenever you try to execute Java programs, that JVM will automatically comment it in RAM. You don't need to tell the JVM go and sit in the RAM like that. Once you try to execute the Java program, automatically it will go and sit in the RAM actually. Okay, sir, now what JVM will do? What JVM will do is, JVM will convert this byte code into machine level language code. Not only that, this machine level language code, it will load onto the memory also. And from the RAM memory, microprocessor will take and produce the output. So, there are two uses of JVM. So, one use is to convert the byte code to what? Machine level code. So, your JVM helps me to convert the byte code to machine level language code. Few people also called as native code or object code or machine code. So, your JVM helps to convert byte code to what? Machine code or native code. Not only that, this code, it will help to load on to what? RAM. So, two advantages. Conversion, loading. If you remember the C program, who used to load that machine code onto the RAM? Loader. But here, JVM only will perform. Anyway, in the further classes, I will discuss in detail what JVM and all those stories. So, till then, this much you remember. So, did everyone understood how the execution of Java program happens? Java program is given to compiler. Compiler generates a class file. Inside the class file, bytecode will be there. That will be given to the JVM. Now, the JVM will generate the machine level code. That machine level code will be loaded onto the RAM. Then the microprocessor will execute. Now, what I will do is, I will copy this bytecode into all the different computers. A very important point, pay attention. So, now, I will copy the bytecodes. I will copy the bytecode. I will copy the bytecode. Here also I will copy the bytecode. How do you copy? I told you by connecting through the network I will transfer, or using the USB pen drive I will just copy and I will paste it here. And in all the computers I have a microprocessor also. Here also microprocessor is there, here also processor, here also processor, here also processors are there. Just now I told, who is the person who will convert the bytecode to the machine level code? Because all the processor can understand only machine level code only. Who is the person? It is a JVM. So, in this computer also I should install the JVM. In this computer also I should install the JVM. In this computer also I should install the JVM. In this computer also I should install the JVM. So now what will happen? This bytecode will be given to the JVM. The JVM will convert the bytecode into native code. Microprocessor will execute and I will get the output. Here also, this bytecode will be given to the JVM. JVM will convert into the machine level code, and machine level code will be given to the microprocessor. Here also I will get the output. Same story, here also I will get the output. Same story, bytecode will be given to the JVM. JVM converts into machine code. Here also I will get the output. So in the previous case, what was the problem? Machine code, if I give, machine code or machine dependent. If I generate the compiled code using Windows operating system, only in Windows operating system they can understand. So that's why what Java people cleverly did was, if I transfer machine code, problem right, no need to transfer the machine code, transfer the byte code, and in all the computers install JVM. In your computer, JVM will not be there by default, you should install it. It will not be there. How to install it all, I will teach you. Maybe in 3 to 4 classes you will get to know. So that JVM will convert the bytecode into what? Machine code. But one important point, for every operating system there is a separate JVMs. So for Windows operating system, you should download Windows JVM and install. For Mac, you should download and install Mac JVM. For Linux, it is Linux JVM. For Unix, it is Unix JVM. So when you go to this Oracle website and when you try to download the JVM, there it will tell whether you want to download JVM for Windows or this is JVM Windows, JVM Linux, JVM Unix, like that options will be there. Whichever operating system you want to download, that operating system JVM, just there will be on download button, click on it, that JVM will get downloaded. In simple words, when you write a Java program, can I execute in any systems? Yes. I have written the Java program in Windows operating system. I can execute in any operating system. I can execute in Windows also, Mac also, Linux also, Unix also. Sir, what about if I change the microprocessor, just in case if it is here Intel, here if I change AMD, no problem. Even though here, if you are using AMD processor also, you are not giving the machine code. You are giving the byte code. That JVM will convert that byte code to such byte codes where your AMD processor will understand. So you don't need to worry internally and all. Internally, JVM will take care of that. So in simple words, what I need to tell you is Java is platform independent. Means what, sir? In any operating system, in any processor, you can execute your Java programs. So what is the definition of platform independent? If a program is compiled in one operating system, and if it is able to execute in any other operating system, then such programs are only called as platform independent, and your Java program is platform independent. Because we are not transferring the object code or machine level code. What we are giving is what? Byte codes. So now when you develop a gaming software in Windows operating system, the other people can use in Mac also, Linux also, Unix also. Hence, many softwares we develop using Java programming language. And I don't know whether you know this or not. 3 billion devices. How many? 3 billion devices runs on Java. So in the day one I asked one question. Which is the most popular language? I think you got the answer. 3 billion devices are running on Java, and Java is platform dependent. So when you code a software using Java, you can execute irrespective of any platforms. But one more important point, your Java program is platform independent, but JVM is platform dependent. What is it, sir? JVM is platform dependent. What does it mean? See here, for Windows I should download separate JVM, for Mac separate JVM, for Linux separate JVM, for Unix separate JVM. Why is that like that? Why means your JVM software is developed using C language. You know, C language is platform dependent or platform independent? Platform dependent, hence even JVM is what? Platform dependent. Why is that? Why this JVM has developed in C language? Sir, they would have developed in Java only. That is the next topic you will get the answer. Why the JVM has been developed in C language? Since JVM is developed in C language, C is a platform dependent, hence JVM is also platform dependent. Hence for separate operating system, you should download separate JVMs. So in simple words, what is happening in C? Pay attention. In C language, when you give high level language to the compiler, what you get is machine level language code. But in Java, when you give the high level language to the compiler, you will not get machine level language code, rather you get byte code. That byte code you give it to JVM, then you get machine level language code. In other words, here directly from high level to machine level using compiler, here from high level you convert it to byte code, that byte code you convert it to machine level code. Am I completely clear? Any confusions? Take the points. Platform independent. Platform independent. Platform independent. Under that, if a program is compiled in one operating system, if a program is compiled in one operating system, if a program is compiled in one operating system, if a program is compiled in one operating system, and can be executed in any other operating system, and can be executed in any other operating system, and can be executed in any other operating system, then it is called as platform independent. Then it is called as platform independent. Then it is called as platform independent. Full stop. In the next line, example Java. Example Java. In the next line, if a Java program is written and compiled If a Java program is written and compiled in one operating system, it can be executed. In any other operating system. Hence it is called as ORA. WORA. In bracket, write once, run anywhere. In bracket, write once, run anywhere. Write once, run anywhere. Write once, run anywhere. Pay attention. See here, I have written the Java code in Windows operating system. So write once. Only one time I have written the Java program. In which operating system I have written? In Windows operating system. Can I run in this computer? Can I execute this bytecode in this particular computer? Yes. Can I run this in this particular computer? Yes. Can I run this in computer? Yes. In this computer can I run? Yes. So one time you write the code. You can execute that code in any computer. That's why it is write once, run anywhere. Run anywhere. Here also you can run. Here also you can run. Here also you can run. In any platform you can run. So that is the beauty of Java. That we call it as ORA. Next, note. There you take note. Java is platform independent. Java is platform independent. But JVM is platform dependent. JVM is platform dependent. Since it is coded in C language. Since JVM is coded in C language. Copy it quickly, pause and copy. Now I have few questions for you people. Pay attention. Java program. Next JVM. Next machine level code. That is the binary code and the byte code. Think and answer. Out of these four, which one is platform independent and platform dependent? Directly don't come to the conclusion. Look at the diagrams. Whatever the diagram that you have written, look the diagram and tell me. Yeah. Whatever the Java program that you have written, is it platform dependent or independent? It is platform independent. Because whatever the Java program that you write in one computer can be executed in any of the other computers. But what about JVM? Correct. Platform dependent. Because for one computer, the corresponding operating system, JVM, we should be installing. And what about machine level code? Very good. It is platform dependent. So if I get the machine code in Windows operating system, it is executed only in the Windows operating system only. Only Windows person can understand that code. If I get the machine code in Mac operating system, only Mac fellow can understand it. But what about bytecode? Look at the diagram and tell me. Now in the previous diagram, I compiled the code in Windows operating system, I got the bytecode. Now that bytecode I transferred into Unix, Linux, other operating system. Did I get the output or not? Yes. Did I change anything in the bytecode? No. In simple words, your bytecode is platform independent. It will run in any of the operating system or any computer. Am I completely clear? Any confusions? Just copy this quickly. Note 4 points you copy it. Just pause and you should copy because I can't give time. Next. The next question is very important question. Take note. Why Java is relatively slow? 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 When compared to C language. When compared to C language. When compared to C language. Why Java is relatively slow when compared to C language? Pay attention. Now assume I write a C program. You know this story. That C program I will give it to compiler. What compiler will generate is the machine level code that is in the form of zeros and ones. That I will give it to the microprocessor. Microprocessor will produce the output. So in this case, directly my high level language is converted to machine level language with the help of what? Compiler. No doubt. Now look at what will happen in the Java program. So if this is my Java program, so this Java program is given to the Java compiler. What Java compiler will generate is a class file. Inside that class file I have a bytecode. So that bytecode I should give it to JVM, and JVM produces the machine level language code. And that gets executed, I will get the output. In other words, here, whatever the code that you have written in high level language code, whatever the code that you have written in high level language code, if you give it to compiler, first you get the bytecode, then that bytecode is given to JVM, then that JVM will produce what? Machine level language code or native code. Here, in one step, I will get the machine level code. But here, in how many steps I will get the machine level code? In 2 steps. That's why Java is little bit slow when compared to C program. So when you are trying to execute the Java program, speed is little bit slow when compared to what? C program. Because in C, directly from high level to machine level, compiler will convert. Here this is a 2-phase event. In the first phase, bytecode. In the second phase, you get the machine level code. Now read the question. Why Java is relatively slow? Why the execution of Java is relatively slow when compared to what? C. Hope you got the answer. Just a minute. Some students had a doubt. Why did JVM they develop in C language? Why did they develop JVM in C language? Because the execution speed in C language is high when compared to Java. That's the reason JVM they did not develop in Java, rather they developed in what? C language. So by keeping speed in mind, so they have developed JVM using C language. Hope your doubt has been clarified. Take out the points. In C language, if the program is given to the compiler, it generates the binary code. Which can be executed. Stop. In case of Java program, when it is given to the compiler, It generates bytecode. It generates bytecode, comma. This bytecode is again given to JVM. This bytecode is again given to JVM. This bytecode is again given to JVM. Is again given to JVM, which generates binary code. Which generates binary code, and hence speed of Java is relatively slow. Speed of Java is relatively slow. When compared to speed of Java is relatively slow when compared to C language. Is relatively slow when compared to C language. Full stop. Below that, copy this diagram. Just pause it and copy it completely. So below that, take down note. Class file. Under that, it is a file generated by the compiler. It is a file generated by the compilation of Java program. It is a file generated by the compilation of Java program. By the compilation of Java program. Full stop in the next line. Class file contains bytecode. Class file contains bytecode. Full stop. A bytecode is neither high level nor machine level code. A bytecode is neither high level nor machine level code.